The choice of apportionment method affects the number of representatives to be apportioned. This is to give conditions by which an apportionment plan is fairly judged. So we have the following criterion of fairness. First is Dakota Rule. That is, the number of representatives apportioned to a state is the standard quota, or one more than the standard quota. So for instance, in example 1, calculating the standard quota of West Cluster is equal to 66 using the Jefferson plan. So it assigns 66 sacks of rice to that cluster. But if the standard quota is 66 and the Jefferson plan assigns 68 sacks of rice to that cluster, which is 2 more than the quota, then this means that the Jefferson plan violates the quota rule. Another fairness criterion is the average constituency. The population of the subgroup divided by the number of representatives from the subgroup and then rounded to the nearest whole number is the average constituency. So let's consider the two clusters, the Jurassic Park and the College Park. The Jurassic Park has a population of 16,000, while the College Park has a population of 8,340, with the following representatives: 10 for the Jurassic Park and 5 for the College Park. To compute for the average constituency for each clusters, we have 16,000 divided by 10, and that will give us 1,600. And 8,340 divided by 5, that will give us 1,668. Since the average constituencies are approximately equal, it seems natural to say both clusters are equally represented. Next criterion of fairness is the absolute unfairness of an apportionment. It is the absolute value of the difference between the average constituency of subgroup A and the average constituency of subgroup B, denoted by this equation. So let's consider the previous example. If the Jurassic Park or the College Park receives the new representative, the average constituency of Jurassic Park will be 16,000 divided by 11, because this is 10 plus the new representative, so that makes 11, and that is equal to 1,455. So since Jurassic Park will receive the new representative, then for College Park will be 8,340 divided by 5, 1,668. But what if College Park will receive the new representative? So this is 16,000 divided by 10 representative. That is as is. And that will give us 1,600. So College Park will receive the new representative. So this is 8,340 divided by 5 plus 1 for the new representative. So that divided by 6. And that will give us 1,390. So to compute for the absolute unfairness of an apportionment, that is the absolute value of 1,668 minus 1,455, and that will give us 213. This one, the absolute value of 1,600 minus 1,390 will give us 210. So since the smaller absolute unfairness of apportionment occurs if College Park will receive the new representative, it might seem that College Park should receive the new representative. A similar process is used when deciding which state should receive another representative. Rather than look at the difference in the absolute unfairness of apportionment, we determine the relative unfairness of an apportionment. This is the quotient of the absolute value of the unfairness of the apportionment and the average constituency of subgroup receiving the new representative. So to determine the relative unfairness of an apportionment that gives a new representative to Jurassic Park rather than College Park and College Park rather than Jurassic Park, we have this. So let us recall the AUA for Jurassic Park, which is 213, and the AUA for College Park is 210. And the average constituency, if Jurassic Park will receive the new representative, is equal to 1,455. And the average constituency, if College Park will receive the new representative, is 1,390. And using the formula for the relative unfairness of an apportionment, we have 213 divided by 1,455, and that is approximately 0.146. And the relative unfairness of an apportionment for College Park rather than Jurassic Park will be 210 divided by 1,390, and that will give us approximately 0.151. When adding a new representative to subgroup, the representative is assigned to the subgroup in such a way as to give the smallest relative unfairness of apportionment, and that is apportionment principle. This principle uses the relative unfairness of an apportionment to determine how to add a representative to an existing apportionment. So for example, from the previous example, the relative unfairness of an apportionment of Jurassic Park is approximately 0.146, and the relative unfairness of an apportionment of College Park is approximately 0.151. By the apportionment principle, the cluster with the smallest RUA is Jurassic Park. Thus, Jurassic Park will receive the new representative.